Brain-machine interface (BMI) is a system to control devices based on brain activities. The current usage of BMI is very limited, especially for healthy people. While using a BMI, the user needs to concentrate and to stay still. At the end, it is much easier to use your own body. One of the goals of our study is to overcome such limitation. If we can control devices just by thinking while doing other things, that would lead to extending human capabilities. With such new possibilities, a BMI can be truly useful for healthy people. We used EEG signals to measure brain activities. 9 electrodes were used. A human-like android robot arm was used. We placed the arm next to the participant to give a feeling that another arm was coming out from the shoulder. The arm moved along a predefined trajectory according to the frequency power of EEG signal. Besides controlling the android arm, we asked participants to perform ball balancing following symbols in a particular order. The trajectory of the ball was tracked to check the performance. At the beginning and the end, participants ran ball balancing sessions to check the changes before and after the BMI sessions. After a short training session to become familiar to the android arm, single task and multitask sessions were performed. Calibration was performed to select the best combination of electrodes and frequency band. While performing the 2 required actions, grasp and release, we measured the frequency power. After all trials, the best combination was selected. In each trial, when the experimenter gave out a bottle, participants imagined grasping it with the android arm. And when the experimenter took it away, participants imagined releasing it and relaxed the android arm. From the results of the multitask session, we found that participants were clearly separated into 2 groups, good and bad performers. The good performers were able to control the android arm in 85% of the trials, while performing another task with their own body.
In this study, we found that half of the participants successfully performed multitasking with BMI, with a relatively high performance of 85%. This was surprising, as usually we need lots of training to reach this performance. And in our study, participants were not just doing BMI, but they had another task as well. In fact, when we checked the performance of single task sessions, the good performance had no significant difference with the rest of the participants. So the good performance, they were not especially good for doing BMI. Rather, I assume that this is more about the ability to distribute and switch attention. Participants who had low performance may have low multitasking ability in general. In our daily life, we are doing lots of multitasking, driving cars, talking while walking. These are good examples. Studies show that as we become old or when we become dementia, our ability to perform such multitasking decreases. So it's very important to keep and recover such ability to maintain our lives. This is one of my research goals. I'm thinking about using our BMI system to train our multitasking ability. In past, we found that controlling robots with BMI gives stronger effect to people compared to body control using motion capture. And we also found that controlling android robots with BMI changes our brain activity. So from these results, I believe there's a possibility that just by trying to move the android arm with BMI, we can train, recover, or even enhance our multitasking ability. Another possibility is, of course, extending what we can do. If we have additional limbs, we can do lots of different kinds of things. Recently, there are several studies on using additional robotic arms, such as playing drums, helping factory works, and so on. But all of them are about single task, to help people do one thing much better. So in that sense, our work is very different. This is about doing different kind of things at once. It's about multitasking. But for now, we have to see further the details of the study. For example, can we do different types of action with a third arm? Is the Android arm necessary, or robot-looking arms? Are they enough? There are many questions that we need to make clear. I hope to build up a more firm theory on what is going on here in the near future.